Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. Okay, like I always say, if you've not subscribed, please do subscribe and turn on the notification bell so that anytime I post a new video, you'll be the first to know. Okay, so we're gonna go straight into this and see what we can do. I'm gonna continue from where we stopped. So I said that we have the 12 laws of indices, and like I said earlier, indices are simply repeated multiplication, right? And in the previous video, I introduced the concepts of indices, and I also told you that the general form of indices is a raised to power n. So where n is the same thing, it's always called the power, all right? Some people call it the index. Some textbook, we call it the exponents. They're all the same thing. Then the a is what we call the base. Is that okay? So for example, 2 raised to power 3 is the same thing as saying 2 times 2 times 2. So that means 2 is the base, 3 is the power, right? Okay, or the index. And if you want to put it in a basic numeral, this is going to give us what? 8. But now we're going to talk about this more deeply now, all right? What are these 12 laws? So what I'm going to do, like what I did with sorts as well, I'm going to list all the laws down, okay? I'm going to list all of them. That in the subsequent videos, I'm going to now take each video, 10 minutes to explain each of the laws, all right? So let's start. So the first one, the first law I'm going to talk about is what we call the multiplication law, all right? Multiplication law. So basically, we're talking about how do we multiply what? Indices together, all right? So the first thing you will know is that the rule says that a raised to power m multiplied by a raised to power n will be equal to a raised to power m plus n. Is that okay? And if we have a constant, okay, k a raised to power m multiplied by j a to power n is going to give us, you multiply the constants together or the coefficients, and that will give us k j a m plus n. Is that okay? So that's the first law. So in the other videos, I'm going to solve examples for each of them. So what I'm going to do here, I'm going to list it all out. So just in case you want to, maybe before you go for exam or you go for a test or go for a viva or something, you can just go to this video and look at all the laws and remind yourself, okay? But in the other videos, I'm going to talk about each and every one of them. Number 2, we're going to talk about the division law, okay? So how do you divide indices, okay? So the first one is a raised to power m divided by a raised to power n. So if you're dividing it, so some textbook will write it like this: a raised to power m divided by a raised to power n is still the same thing, all right? So what will happen is going to give you a raised to power m minus n. Is that okay? And also, if you have coefficients or constants attached to the index, so and j a to power n will be equal to, so you divide the coefficient, it's going to be k over j, then a m minus n. So that's how you do it. So for the multiplication, you multiply 2 together. So we're multiplying 2 index together. What you do, you add them together. But when you're dividing, you divide the constants. Is that okay? Number 3 is what we call the power of 0. Okay, so the power of 0. So this rule is very simple. What it says is that anything raised to power 0 is equal to 1. Okay, so regardless the number, anything raised to power 0 is equal to 1. The second one is if there's a constant and it's a raised to power 0, because this is already equal to 1, so it will be equal to the constant. Is that okay? So that means if you have a raised to power 0, it's going to be equal to 1. Now, if you have a constant multiplying it, it's going to be k, or that constant itself. Then number 4. Okay, remember it's 12 laws, so we have 4, we're 30%, we're getting there. The next one is what I call the brackets with indices. Okay, the brackets with indices. Now, with bracket with indices is something similar to what you know already, but I'm going to just go over all the possible formats that this can come in. so that you'll be very conversant with it. So it's a raised to the power m all raised to the power n. So when you are having an index in a bracket raised to the power, what you do, you multiply the powers together. So it's going to give you a raised to the power m times n, and that will give you a raised to the power what? Mn. So like I said, don't worry, I'm going to solve examples for this, okay? So I'm just going to list all the laws. So the next video, I'm going to be taking each of these laws and we're going to be solving example for them. Is that all right? Then the next one is if we have a b raised to the power n, which is the same thing as saying a times b raised to the power n. So you can come in this format or you can come in that format. It's still the same thing. It's going to be a raised to the power n, b raised to the power n. So technically, if you look at this, it's same thing as say a raised to the power 1, b raised to the power 1, all raised to the power n. Is that making sense? So basically, you multiply 1 times n will give you n. 1 times n will also give you n. So it's the same thing, all right? So when you are having the, you're multiplying 2 together, all right? The power affects all the powers of all the elements inside the bracket. So just to further explain what I just said, that's where the third one comes in. So if you have a raised to the power L and b raised to the power n, all multiplied by m, okay? This is the same thing. It's going to be, you multiply each of the powers. So it's going to be a raised to the power lm and b raised to the power nm, all right? Now, the same concept, if we have constants, all right? So let's say for the first one, we have a constant outside the bracket. So we have a raised to the power m all n, and that will give you k a m n. So basically what you do, you multiply this 2 as well, and after multiplying it, the next thing you do is that you now multiply it by the constant. Is that all right? So the next one, number 5, is if we have the k for the second one, so KAB, all right? So we have AB raised to the power n. It's going to be the same answer we have, but we're just going to put the constant here outside. Is that okay? And the last one, the same thing if you have a constant with this as well. So it's you will solve it as normal as we've solved it before, but the only thing is that the constant is going to multiply all of them together. And B and M. Okay. So also there are other ones you can also see around. So if you have something like anyway, anyhow it comes around. So if you see something like a b raised by m multiplied by a constant, basically what you do is that you multiply the power with everything in the bracket, then a constant, you're going to multiply it outside. This is very important because indices is very important in most solvings. When we talk about differentiation, when we're going to talk about integration and the rest of it, or we're going to talk about simplification, all right? So you need to understand these rules together, all right? Number 5, the next one is what we call the negative power. So the negative power. So if you have a negative power, what does that imply? So the other one is a raised to the power minus n. So when you have a raised to the power minus n, is the same thing as saying 1 over a raised to the power what? N. And if you have a constant, so you have ka minus n, is the same thing as saying k multiplied by, because we already know that a raised to the power minus n is 1 over a raised to the power n. So therefore, the answer is going to give us k over a raised to the power what? N. And that is number 5. Number 6, we're halfway there now. We're going to have what I call the fractional base. So the fractional base and brackets with power. Fractional base and brackets with power. So fractional base and bracket with power. So in this case, what I'm trying to say is that now the base we're having now is in fraction, okay? So the base now we are having now is in fraction. So that means, for example, if I have A over B, all raised to power M, okay? So the same thing, the power is going to multiply each and every one of them. So it's going to be A raised to power M, are you seeing it? Over B raised to power what? M. And also, if there is a constant, we have K, A over B raised to power M is going to give us the same thing. You solve this as usual, but you're going to multiply it by what? K raised to power what? K value. So that means if you have a particular constant, you open the bracket, they multiply it by the what? Constant. The next one is if we have A over B raised to power M divided by N, okay? So let me write this a little better. So we have A over B, all raised to power M over N. Is that okay? So the same thing. So far you have a power, you multiply all the elements in the bracket with it. So that will give you A raised to power M over N divided by B raised to power what? M over N. And if you have a coefficient, okay, if you have a coefficient, the same thing is going to happen. If you have a coefficient, it's going to be K A over B raised to power M over N. The same thing, you solve this as usual to give you this, then you multiply your answer together with a coefficient. So it's going to be K A M over N divided by B M over N. That's number 6. Number 7, okay? The 7th law, so don't worry, we're going to talk about each and every one of this. Now, what about if we have a positive fractional power? Okay, this time we're having a positive fractional power, all right? That's number 7, positive fractional power. Now, what do you do? The same thing we have. So if we have now this time, we're talking about the power now is now in fractions. So what does that mean? How do we solve that? So the positive fractional power, what it states is that A raised by 1 over N is the same thing as saying the nth root of A. Is that making sense? It's equal to the nth root of A. Now, if you also have the constant as well, okay? If you have the constant and 1 over N is going to be the same thing, K multiplied by the what? The nth root of A. So when there is an N, so the value you have here is going to be the nth root of that. Now the next one is if you have in this case, you have A raised by M over N, okay? So that means this is the power. So it's going to be, so the nth root, we already agreed that if there's N is the nth root of A, then all raised to power what? M. Or some textbook can write it as A raised to power M, then the nth roots. Any of this will give you the same thing, all right? Now, usually the format to use would depend on the question itself, all right? I'm going to solve that very soon. I'm going to solve some questions very soon. Now, the next one, this is 3. The next one is 4. When we have a constant, all right, it's going to be the same thing. It's going to be either you have a constant, then you have the M roots. So if this is M now, so it does not really matter, but let me just, for consistency, let me say M over N. Is that okay? So it does not matter. So it's going to be the nth root of A, M, or it will be K multiplied by the nth root of A raised to power M. Okay? So that is it. So that is number 7. Now, number 8. We have the positive fractional power. So I call it the positive fractional power or fractional base power and brackets with power and brackets with powers. So in this case, we are having a positive fractional power and brackets with power. So let's look at an example. We have a 1 over m power n. So it's positive fractional base power and brackets with power. The same thing, similar to this rule here. Remember where I told you that where you multiply the power with rule 4, okay? Similar to the rule, you also multiply this, and that will give you a n over what? M. And we're back to number 7. Are you seeing it? Which is the same thing. Remember I said the value you have here is the m truth. So it's going to be the m truth of a raised to the power n, or you can say the m truth of a all raised to the power what? N. Are you seeing it? And if you have a constant, the same thing is going to happen. If you have a constant, a 1 over m all raised to the power n, the same thing is going to be k a n over m, which is the same thing as k into brackets. So remember I said the value you have down here is going to be the m truth of a all raised to the power n, or it can be k, the m truth of a to the power what? N. Then the next one is if we have a n over m multiplied raised to the power x. The same thing, similar to the rule 4 that I told you that you have to multiply the powers. So you also multiply the powers here. So it's going to be a n x over what? M. Then the same thing is going to be the m truth of a raised to the power nx, or the m truth of a all raised to the power what? Nx. So you can see the other following rules are just a build up on the previous ones. Is that okay? Now, if you have a constant, the same principle will apply. So if you have a constant or a coefficient, depending, raised to the power x, the same thing is going to give us k a n x over m. And that will give us, you multiply all this, it's going to be the m truth of a nx, or it can be k into the m truth of a all raised to the power what? Nx. Okay? Now that is the 8th rule. So the next one is number 9. The number 9, I call it a negative fractional power. Number 9 is called a negative fractional power. Is that okay? So for example, if you have, it's similar to the negative power. So if you remember the negative power, all right? But this time the power is going to be a fraction, okay? And remember, I told you here that when you want to remove the negative power, you have to flip it or find the inverse. Is that okay? So in this case now, we are having a negative fractional power. So we are having something like a minus 1 over m. So it's the same thing as saying 1 over, to remove the negative, a raised to the power 1 over m, which is the same thing as saying 1 over the mth root of what? A. Remember I told you, if there is the value here is going to be the mth root of the what? The base. Now, if there is a constant, okay, if we have k a minus 1 over m, so it's the same thing. You just multiply k multiplied by this. We already know that to be 1 over a 1 over m. And that will give us k divided by the a 1 over m, which is the same thing as saying k over what? The mth root of a. Now the next one, the third one under this. So if we're having the same thing, a minus n over m, now that will give us 1. To remove the negative sign, it's going to be 1 over a n over m. Okay? And that's the same thing as saying 1 divided by, like I said, in this rule here, okay? That the bottom one is going to be the nth root, and that will be the power, right? So The bottom one is going to be the mth root of what? A raised to the power n, or you can say 1 over the mth root of A all raised to the power what? N. Like I said, please don't get scared, okay? I'm going to solve examples for each of these rules, okay, in the subsequent videos. All right, so don't get scared about it. It's very, very easy. It's very easy. I can promise you that. So the next one, if you have a constant and we have A minus N over M, the same thing, we have a constant. So if you notice, multiply by 1 over A N over M, and that will give you the K over A N over M, which is the same thing as saying the K over the mth root of A to the power N, or you can say K divided by the mth root of A all raised to the power what? N. Are you seeing it? And that'll be number 9. Okay, so let's go. We're almost there. 3 more to go. Number 10. Number 10 is called the fractional base and bracket with negative fractional power. So it's called the fractional base and bracket with negative fractional power. Okay, so this is what I call it, the fractional base and bracket with negative fractional power. So, for instance, if you have A over B having minus 1 over N, so in order to remove, so remember when I told you with negative power, that to remove it, you have to flip it, right? Okay, to remove the negative, you have to flip it. And the same thing, when we had a negative here, we also flipped it, all right? So the same thing, but if the base is also a fraction, you also flip it. So it's going to become B over A. Are you seeing it? So when it's a fraction, you flip it as well. Raised to power what? Minus, because the minus have gone, because you flipped it, it's going to just become 1 over what? N. So to remove the negative sign, you flip it, and this is not going to give you, you apply the other rule we talked about, where we said you then multiply the power by the value. Okay, here. So number 6, fractional base, when you have a power, you then multiply the power by each of the what? Elements inside. So that means this is going to give us B, 1 over N, divided by A, 1 over N. And this will now give us the other rule. When you're having 1 over something, the N is the same thing as the nth root of A, okay? So that means this is going to be the nth root of B divided by the nth root of A, okay? Now, if you have a constant as well, the same principle will apply. So have a constant for this. The constant will be A over B minus 1 over N. So the constant now, because we already know this, will become the constant, and you flip this. It's going to be B over A, 1 over N. And that will give us K, B, 1 over N, divided by A, 1 over N. And the same thing to be K, the nth root of B, divided by the what? The nth root of what? A. All right? So let's show in another one. So if, for instance, you have A over B, and we have minus M over N. The same thing. To remove this negative sign and you have a fractional base, you just have to flip it. It's going to be B over A raised to power what? M over N. Okay? The same thing. You multiply it. It's going to be B M over N. And it's going to be A M over what? N. And like I said, it's the same thing as saying the nth root of B raised to power M over the nth root of A raised to power M. Or you can say the nth root of B, all raised to power what? M, divided by what? The nth root of A, all raised to power what? M. So different ways to solve it. Then number 4, if we have a constant, we have A over B raised to power minus M over N. So the constant now will multiply everything. Then you flip this to remove the minus. So it's the same thing, but we just have the constant added to it. Then it's going to be the K, B, M over N, and A, M over what? N. And that will give you the constant, the nth root of B, M, divided by the nth root of what? A, M. Or we can have a constant, which is the nth root of B, all raised to power what? M, divided by the nth root of A, all raised to power what? M. And that is the 10th rule. Now, the 11th one is what I call the equalities. Is that okay? The 11th one is what I call the equalities. Now, for the equalities, it's very simple. It said if A raised to power M is equal to A raised to power N, so therefore M must be equal to N. Is that okay? And number 2, it says if A raised to power N is equal to B raised to power N and A is not equal to B, for these two to be equal, N must be equal to what? 0. Is that okay? Don't worry, I'm going to solve questions on this. Is that okay? I'll solve questions on this. So that's the 11th rule. Like I said, the aim of this video is to list all the rules for you so that you can be conversant with all the rules. And then you can also skip through the videos in the playlist and know which one you want to understand further on. Number 12 is what I call the power of powers. The power of what? Powers. Okay? It's when we have x raised to power y and y raised to power z will be equal to x raised to power y raised to power what? Z. Is that okay? And that are the 12 rules on this. Okay, so these are the 12 rules. It was a long journey. We talked about the multiplication, division, the power of 0, the brackets with indices, negative power, fractional base and bracket with powers, positive fractional power, positive fractional base power and brackets with powers, negative fractional powers, fractional base and bracket with negative fractional powers, equalities, and finally the power of what? Powers. All right, so the next video, I'm going to start straight with the multiplication law. So I'll see you in the next video. I'm going to start solving examples for each of them. I'll pick one, the first one with multiplication, and I'll go to division and go in that order till I get to the 12 laws, all right? So I'm going to see you on this journey, and I hope that at the end of this, you'll be very, very good with the laws of indices, all right? So I'm going to see you very soon. And please don't forget to like or subscribe and turn on the notification button so that you will know when I post new videos. All right? Thank you very much.